Hey everybody, welcome back. Today we're doing IM2 Notes 9.1.3. What does the equation reveal? Now in Chapter 5 we graphed quadratic functions in standard form. That's y equals ax squared plus bx plus c. And factored form, that's y equals ax minus p times x minus q. However, in the last lesson, we transformed graphs of quadratic functions using a new form of the equation. And that form is called graphing form. Y equals ax minus h squared plus k. Now, today we have a couple of learning goals. They are, and we'll write these in first person, I will be able to, 1, apply the method of completing the square to rewrite quadratic functions in graphing form and use the vertex form to efficiently graph parabolas and I will be able to rewrite quadratic functions in different forms, those being standard, factored, and graphing. Now throughout these notes I will use the word graphing forms, the phrase graphing form and vertex form interchangeably. The most important learning goal today is number 2, that you'll be able to rewrite quadratic functions in different forms. Completing the square is one way we can do it, but we'll also have to be able to go in other directions. Okay, let's get started. 9-23. Anissa is looking over her work from 5.1.2. She wrote down the equation g of x equals x minus 3 squared minus 4, but she cannot find the graph that goes with it. Based on what we did in the last lesson, we're going to sketch the graph of g of x equals x minus 3 squared minus 4, and then we will describe how it is a transformation from the graph f of x equals x squared. Where is the vertex of the graph for f of x? Where is the vertex of the transform graph, g of x? Here we go. So, for g of x, I notice that I have h and k readily available, and my vertex is going to be at 3, negative 4. Taking care to remember that this minus 3 moves us to the right, which is not intuitive, and negative 4 moves us down. So let's plot that vertex. I go over 3, 1, 2, 3, down 4, 1, 2, 3, 4, and then I have my vertex. Now I notice that a equals 1, so I'm going to do my step pattern as 1, 3, 5. I go over 1, up 1, there's a point. I go over 1, up 3, there's another. I go over 1, up 1, 2, 3, 4, 5, there's another point, and I can mirror these. Smooth curve. Okay, now the vertex of f of x that's my parent function, x squared, is going to be 0, 0. And that also has a step function of 1, 3, 5. Okay, I'll graph that. Excuse me. Determine the x and y intercepts of the parabola from Anisa's equation. Okay, so the equation is g of x equals x minus 3 squared minus 4. For the x-intercepts, I have to do a little bit of work, but for my y-intercepts, it's pretty okay. Y-intercept, to find the y-intercept, I set x equal to 0. So that's going to be 0 minus 3 squared minus 4, which is 9 minus 4, which is 5. So I have my y-intercept at 0, 5. For my x-intercept, I set y equal to 0 and solve the resulting equation. Set g of x is for my y in this case equal to 0. So I have 0 equals x minus 3 squared minus 4. The first thing I'll do is add 4 to both sides, which has this impact. 4 equals x minus 3 squared. Then I take the square root of both sides, and I get plus or minus 2 equals x minus 3. Now if I solve this, I get 2 possible equations to solve from. 2 equals x minus 3, and negative 2 equals x minus 3. Solving both of these gets me x can be either 5 or 1, meaning my x-intercepts are at 5, 0, and 1, 0. Okay, we continue. Now I'm going to rewrite Anisa's equation in 3 forms. Okay, graphing form. I have y equals x minus 3 squared minus 4. And what information does this form reveal about the graph? Well, it tells us the vertex is 3, 4, and A is 1. This comes from the graphing form equation, which is y equals a x minus h squared plus a. Okay, now let's write it in standard form. To get it into standard form, I need to make it look like y equals ax squared plus bx plus c. And what's in my way? Well, the x minus 3 squared needs to be expanded. So I take that and I make a little box, and I have x squared minus 3x and positive 9. I add all the pieces together. I have x squared minus 6x plus 9. And from that, I'm almost done. So originally I had y equals x minus 3 squared minus 4. Now I can rewrite that as x squared minus 6x plus 9. That's what x minus 3 squared equals. And then from that, I subtract my 4, and I end up with y equals x squared minus 6x plus 5. This form, my graphing form, tells us where the vertex and what A is and what A is. My standard form allows you to quickly see the y-intercept. So this form reveals REVEAL, reveals the y-intercept. It's at 0, 5, and A is 1. So I can get A from either version. Okay, now let's put this into factored form. Now, not everything is factorable, so this won't always be possible, but here we go. This should be factorable since I have my x-intercepts. So I have x squared minus 6x plus 5, and I want to factor that. Okay, I need two numbers that multiply to 5 and add to negative 6. Well, I happen to know that negative 1 times negative 5 is both positive 5 if you multiply those numbers together, and negative 6 if you add those numbers together. So I have negative x and negative 5x, and I finish factoring. And that gets me y equals x minus 5 times x minus 1. And this form reveals my x-intercepts. Now let's see. Am I missing anything? Can I find anything else in these equations? It's tempting to say that this reveals A, and it does, but only if you don't have a coefficient of x in either factor. So I'm not going to say that because it wouldn't always be true. Over here, I don't see anything else that I can immediately get from it. And over here, well, what about my line of symmetry? My line of symmetry is x equals 3 because it is the line that cuts the vertex. Okay, let's continue. Now we're going to sketch the graph using the equation from the previous problem, just to remind us. This is for y equals x minus 5 times x minus 1. And from that, I get my x-intercepts are at 5, 0, and 1, 0. So 1, 2, 3, 4, 5. I have an x-intercept here, and 1. I have an x-intercept here, and I go exactly between them to find my line of symmetry. See. And that is at x equals 1, 2, 3. And I plug in my line of symmetry to my equation to find my vertex. So the y part of my vertex is going to be 3 minus 5 times 3 minus 1, which is negative 2 times positive 2, and that's negative 4. And I plot that. 1, 2, 3, 4. And then I connect my points with a smooth curve. That last part could have been smoother. Good enough. Okay. I can graph a quadratic function that way, but look, I don't want to. I would prefer to use graphing form. Graphing form in this case it would be y equals x minus 3 squared minus 4 is the most useful? Because it directly provides the vertex and general shape of the parabola. Why did we teach you with factored form first? To emphasize how important it is to see that this graph is symmetric, to make you go in between those x-intercepts every single time, to reinforce the symmetry of this graph. But that is not the easiest way to do this. The easiest way to graph a parabola is from graphing form. Okay, next problem. A function in the form f of x equals a times x minus h squared plus k is said to be in graphing form with a locator point of hk. This is vocabulary. For a quadratic function, another name for this form is vertex form. Why is that appropriate? Okay, this is not a trick question. This is appropriate because the vertex of the parabola is directly given by the hk values in the equation f of x equals a x minus h squared plus k. And that's that. Okay, we continue to 924. In the previous problem, we rewrote Anisa's function from graphing form to standard form. How can we reverse this process? How can we go from standard form to graphing form? So we consider the function f of x equals x squared minus 6x. And we say, hey, how can I do this? Well, my wonderful students, we are going to complete the square. So we use the process of completing the square. Okay, I start with f of x equals x squared plus 6x, sorry, not plus 6x, minus 6x plus 5, and then I need to make this part into a square. So I have x squared minus 3x, I'm breaking that 6 up completely, minus 3x, x minus 3, x minus 3. And this missing piece, the piece that I am adding to the equation, is 9. So I'll rewrite my equation. This becomes f of x equals x squared minus 6x plus 9. The 9 that I'm doing right now comes from this box. And then here's the thing. I can't actually just add 9 all willy-nilly to my function. I also have to subtract it so that I don't change the truth value of this equation. So this is just like adding 0, but it's really useful. This becomes f of x equals x minus 3 squared. That comes from the outside of my box. So that comes from right here. It's another way of writing this part. And then that equals the pink up top. And I have to remember to deal with this part. So this turns into -4. And my final equation is f of x equals x minus 3 squared minus 4. Let's do that a couple times through just to practice. That's going to be 925. 925 says that in Chapter 5, we used the process of completing the square to rewrite quadratic equations in perfect square form. For example, by completing the square, we could rewrite x squared plus 4x plus 1 equals 0 in perfect square form as x plus 2 squared equals 3. Excuse me. The process of completing the square can also be used to rewrite a quadratic function in standard form into graphing form. We're going to do that by rewriting these next equations into graphic form. So part A says f of x is x squared plus 6x plus 9. So I'm going to complete that square. This part turns into x, and then I break this into 3x and 3x. I break it perfectly in half. And then I have x plus 3, x plus 3. And what does it take to complete this? Well, 9. So for this particular problem, I have f of x equals x plus 3 squared, but then I have to take this 9 away because that's hiding inside there. So minus 9, and then I have to add this 9 on because it's still there, plus 9, which just becomes f of x equals x plus 3 squared. Okay, the next one is x squared plus 6x plus 1. So first I'm going to complete the square for this piece. I do, again, it's the same as the last one, x squared, 3x, 3x, x3, 9. And that gets me x squared plus 6x plus 9. And then I have to subtract that 9. Then I have to add that 1. So that's x plus 3 squared minus 8. That is what g of x equals. Okay, let's keep going. We're going to complete the square for each of these. Ready? All right. So I've got x minus 4 squared. I'm going to take the minus 4 and break that in half. So minus 2x, x squared goes here. Then I do the outside, x minus 2, x minus 2. I square negative 2, I get positive 4. This equation I rewrite as x squared minus 4x plus 4. Then I subtract that 4 and add my 3. Let me color code what I'm subtracting and adding. So this 4 that I used to complete the square, I need to subtract that value in my equation. And this 3 that was part of my original equation, I need to make sure that I remember to add that on. My final answer becomes x minus 2 squared minus 1. That's what f of x is if you write it in graphing form. Okay, now let's do part B. Okay, I need to break up the pieces. So I take minus 3 and I break it in half. I get negative 1.5x for each of these pieces. I have x squared. That's x minus 1.5, x minus 1.5. In this piece, I'm going to get 1.5 squared. So 1.5 squared, doing that in my calculator, gets me 2.25. So that means I have x squared minus 3x plus 2.25 minus 2.25 minus 5. And let me color code the pieces again. So the piece that I'm subtracting comes from this part of my square, because if I add it on, I'd better subtract it. Otherwise, I change the truth value of my equation. And the minus 5 comes from my original equation in standard form. So I can't ignore that minus 5. I just hadn't paid attention to it yet. Okay? My final equation becomes g of x equals x minus 1.5 squared minus 7.25. Okay, we keep going. Now this one's a little bit harder. Before we can complete the square, we have to deal with the fact that there is a 2 in front. So that's what we're going to do. I'll factor out that 2. So this becomes 2x squared plus 8x plus, let's see, what's 29 divided by 2? 14.5. And now I complete the square for this part. So I have 4x and 4x and x squared, x plus 4, x plus 4, 4 squared is 16. So this gets me 2 times x squared plus 8x plus 16. I have to subtract that 16. And then I have to remember to add that 14.5, which gets me 2 times x plus 4 squared minus, what's negative 16 plus 14.5? $1.5. And I'm still not done. Well, no, I'm not, because this is not graphing form yet. This becomes 2x plus 4 squared minus 3. And that's what j of x equals. Okay. A little messy, but I can make it work. Now we're going to do k. Now in part C, there was a leading coefficient of 2. That's the coefficient of x squared. In D, there's a leading coefficient of negative 1. And I still have to deal with it. I can't just start completing the square until the coefficient of x squared is 1. So I'm going to divide all of my terms by negative 1. Well, I'm going to factor negative 1 out. So that's negative 1 times x squared plus 8x plus 16. Now I'll complete this square. But actually, what I notice here is that this is a perfect square equation. This is actually the second perfect square equation of the day. I'll scroll back up to the previous one. This equation was also a perfect square equation. When you have x squared plus bx plus b over 2 quantity squared, that's going to be equal to x plus b over 2 quantity squared. And I see that happening here. So you can do all the steps to complete the square, but if you remember your special case factoring and you can see that this is -1 times x plus 4 squared, even better. Because special case factoring is something that will save you a lot of time as you progress in mathematics. Factoring is always going to be with us. It's nice if we can do it with special cases. Okay. Now we're going to sketch our parabolas from parts A through D. And to make that easier, I'm going to write their equations. So for A, I have f of x is equal to x minus 2 squared minus 1. For B, I have g of x is equal to x minus 1.5 squared minus 7.25. For C, I have j of x is equal to 2x plus 4 squared minus 3. And for D, I have k of x is equal to, oh, I made a mistake on k of x, everybody. I'm so sorry. I misread the problem. Let's go back and fix it. I thought that this was a plus sign. I'm going to make it a plus sign so that we don't have to completely redo the problem. K of x is equal to negative x plus 4 squared. Let's graph these. Okay, part A. My vertex is at 2, -1. My A is equal to 1, so my step is just 1, 3, 5. I go over 2, I go down 1. That's my vertex. And then I do my step pattern of over 1, up 1, over 1, up 3, over 1, up 5. I'm being approximate. And then I connect with a smooth curve. And I label, let's do my vertex and at least 2 other points. 2, -1. I'll label this point. This is, let's see, from 2 I've gone over 2, so that's 5. And from 2 I've gone up 4, so that's, no, from -1 I've gone up 4, so that's 3. And this is its mirror point, so it's 0, 3. Okay, next problem. I have x minus 1.5, so I go over 1 and about half more. And y is -7.25, so I'll go down 7. 1, 2, 3, 4, 5, 6, 7, and a little bit more. There we go. 1.5, -7.25. And then my step pattern is over 1, up 1. And then over 1, up 3, because, well, let's just write everything out. The vertex is 1.5, comma, -7.25. My A is 1, so my step is 1, 3, 5. Mirror points, smooth curve. And if you miss a point, just make the dot bigger. No big deal. If we had graph paper, we could be more precise. Whether or not you're really precise with your points, though, you should never have a pointy vertex. That's a different kind of graph. Okay, next. So now we have j of x equals 2, x plus 4 squared minus 3. So my vertex is at -4, -3. My A value is 2, so my step is 2 times 1, 3, 5 is 2, 6, 10. Okay. 1, 2, 3, 4. 1, 2, 3. There's my vertex. -4, -3. Okay, now I'm going to do my step pattern. I go over 1, up 2. I go over another one, up 6. 1, 2, 4, 6. And then I mirror that. And I connect with a smooth curve. Okay. Next, my vertex is at -4, 0. This is the same as if I had written +0. My A value is -1, so my step is -1 times 1, 3, 5. That's -1, -3, -5. So let's do my vertex. 1, 2, 3, 4. -4, comma, 0. And my step is I go over 1, down 1, over 1, down 3, over 1, down 5. And then I mirror those. Okay, smooth curve. Smooth as you can make it. Don't let it look pointy. And that was my last problem. So, wonderful students in this beautiful class. I hope you have a great day. And I look forward to our next lesson together. Bye.